Dasenbrock?
Yep.
Geotechnical engineer with the Minnesota Department of Transportation. His current work emphasis at MnDOT are geotechnical testing, modeling, instrumentation, and performance monitoring. He's on the implementation team for the FHWA EDC5 Advanced Geotechnical Exploration Methods Initiative and the conference chair for the upcoming 2020 ASCE Geo Institute Geo Congress in Minneapolis.
Cool.
Thank you.
Thank you. Good afternoon, everyone. I am hoping to make the final presentation of the day one of those that makes you glad you stayed, because I know I'm the only thing between you and the munchies out in the other room, and because with the topic of immersion, we've got some exciting things to share on the geotechnical forefront. So I brought along today one of these HoloLenses that people earlier have been talking about. So my goal is essentially to share with you right now what I'm seeing, and what I'm seeing is you. And some gentlemen are already participating. Hi, I'm Derrick. Introduce yourselves later. Hey, Nancy, you made it. Cool. All right, so right now, if the tech is working properly, you should be seeing the auditorium and yourselves and this little box kind of here, which is my augmented reality. And thankfully, the acoustics in this room are really good, so I'm probably going to step away and move around. Once I say, go over here, I do the pinch, and I start our GeoCongress presentation that we shared earlier. And I was in here mapping the room before, so with any luck, the hologram is still here. The pixels in space are hopefully going to be right out there sometime soon. So let's see here. If I go back to the home screen, it should be starting up. And one of the dangers with real-time demos is that you have to sort of trust that everything will work out. And I may have launched two aspects of what's running here, so we'll try again with me, like staring off into space here. And so let's see, the auditorium. All right, a couple more commands. We'll bring that back. Go over here. The virtual world will be playing friendly with me, and we'll see where we go. They assured me it would work back when we did our 5 or 6 tests. So let's see, logos coming up, because everybody likes to tell you their stuff, right? And now, it may or may not tell me. All right, so I have some options here. I can select to host, I can join in what some other people are seeing. At the moment, I'm going to do it solo, because the fine folks at Federal Highways only trusted me with one of these. All right, so with luck, things are starting. Am I building anticipation? Yes. Excellent. All right. It all worked well in pre-production. All right. Famous last words. Yeah, I know. Let's see. All right, where am I going? Yes, I'm going to try not to fall off. So there are some commands and some other things. All right, looking around. All right, is the map where you expect it to be? The map is sort of right out in here, so I'm going to say yes. So I'm going to confirm the map is where I expect it to be. And then maybe I'll go down the steps, because I can actually see, at least a little bit, without wearing one of the Oculus Rift goggles. So you didn't realize you'd be in the middle of a virtual experience, did you? Computer, next. Hello, computer. All right, so right now, with any luck, you are seeing what looks like a landform in space in kind of the seats in front of us here. Are we good? Yep. I'm not going to turn around because that'll mess something up, I'm sure. I only have the Jedi novice training and not the master level training. But the whole idea is that I am showing you on the screen in 2D what I am seeing in 3D in space in the auditorium. So if I had a big conference room or a conference table and more people have the HoloLens, you would be seeing the 3D model in space here in about rows 1 through 5. So one of the things I needed to learn from the training is not to make too many gestures in front of the HoloLens, because it now has the menu in front of me, and I don't know that they necessarily trained me how to get rid of that. Let's see, if I go back to the home screen for the moment, that might get rid of everything. Yes. All right, we'll try again. Real-time demos are like this. It should come back right where I was, if all goes well. All right. I am now not going to move my hands in front of my face, except when I intend to do something. That'll help. So this is a map of an area on the West Coast. For geotechnical engineering, we use a lot of information to try to help our colleagues in other civil engineering disciplines. We can use the techniques right now for scoping. We can use some of the information that the HoloLens lets us do for design and analysis, but certainly for decision making, allowing people to understand alternatives that are based below the ground surface, because it's not everything up above with traffic that necessarily makes a difference. So one of the things that I can do, I've got this map here that shows a variety of alignments. We've got the coastline out on the left side over there, and there's been some troubles. The red alignment is what's currently there, and hopefully the cursor is kind of scanning along the red alignment right in this area, kind of around here. There's been some landslide trouble, and we'll visit that in a moment. And a lot of the planners said, hey, the best thing to do is going to be just go way over from the coastline, go over here into this green space. Turns out right-of-way is cheap over there. I'll get to that in a moment as to why the right-of-way might be inexpensive. But perhaps we can study that. One of the things that we have available to us today that we didn't maybe many years ago is LiDAR, and that allows us to do aerial flights where we can do now these texture maps, and we can look around, and sometimes the model gets confused, so I'm not going to go over there quite so much. But we can see the landforms and some of the terrain that might make things difficult for us. So continuing on, we might want to dig a trench. We might want to see what's in the ground for an area where maybe there was some seismicity or some other problems. And so now I can look and I can see exactly what the people who are doing the mapping of the trench are seeing. And I can see it potentially here full scale. And I can look around and I can make notes. I can include a legend up here, so I can say, what are those sticks and things anyway? Macro charcoal samples and sediment samples for luminescence dating. So I've got some of those going in here. But now maybe I can share this remotely with other engineers who are back in the office if I'm looking at this in the field. Or maybe I can use it as a public meeting for a presentation. But I can share all this mapping with my colleagues. And maybe it was difficult to drill through here. You can see there are a lot of rocks and boulders. So a lot of information that might be useful. I can maybe blow it up a little bit as if I'm standing down in the trench. I bet you guys didn't realize this was all here in the auditorium. That's kind of cool, right? So looking around, maybe getting an idea of what's happening in the 3D space. All right, so now I'm back to my model. I've worked with my geologists. They have done some mapping for us, so now they've put some colors on the terrain. Maybe we have some alluvial and fluvial deposits and some things to potentially worry about in terms of the landforms and the types of geomaterials that we have. So now let's talk a little bit about where we're going to go. We just visited that trench right here in the bottom, and we're going to navigate quickly through some of the other spaces here, starting with this big blue patch. So right now, we've got some areas here where I can kind of look around, and I've got these white areas up and down. Now I can make some adjustments here, so it's, I'm kind of blocked and obscured by this mountain, right? What's behind that? All right, so now I'm going to look over here, and if all works well, I'm going to grab this height adjustment and lower the model a little bit. Okay, with any luck, I will look back, and the model will be somewhere. Ah, it's down here, bird's eye view. All right, so now I see a lot of things where, oh, maybe there's going to be a big fill section here in the roadway and some cuts up here, and then another fill section down here and some other areas. This is a lot of earthwork. I mean, the contractors are going to love that, right? Pulling in hundreds of thousands of cubic feet or meters, if you prefer, of material. And of course, all that's going to be very economical and perfectly safe because we're in a landslide-prone environment, right? Maybe not. That was sarcastic. All right, so let's move the model back up and somewhere, and let's see. Now I'm underneath, maybe a little bit too far. So, all right, sweet spot right here, maybe. Ah, there we are again. Pretty good. So those are some things that we can do as far as controlling the model and looking around. So let's head over here to kind of the coastal area that we're looking at. Some other things that can, let's see, the model may have shifted slightly on me. One of the problems of not putting it on a nice flat table or practicing in the hotel is that it moves around with the reference. A lot of the chairs look the same. So let me see if, make sure I'm not missing anything here as we fly along. It turns out it's one of the other techniques that we have that we can use in geoengineering. It's from our folks in mapping. We can use different types of techniques. I did it again. I careful when you do the bloom gesture. I'll just leave it there for the moment. Hopefully it's not too distracting for you. So the color map here actually indicates the landslides that are in the area and active. And all right. I did not master the training, E-. So the hotter colors are areas where the landform is moving up and away or toward the satellite, and the blue areas are areas of depression, or where the material is moving downward. So you can see in this kind of blue area, we have some landslide movement where material is going from the blue area, and it's accruing here in this kind of reddish area. And you can see that over top of this roadway right here, it's tumbled down on top, so that's going to be a problem. So this might be an area that we need to repair unless we move the roadway. In order to do that, they did some modeling. They said it's going to take a lot of steel in the ground and some concrete. That's entirely possible. With some design analysis, and this is a bit of a rendering of what it would look like. The yellow areas are flat terraces for construction equipment to work on. Because one of the nice things about models like these is you can use it for constructability. And so we're going to need to do some work in there should we stay on those alignments. One of the things that we have as a trouble in geotechnical engineering sometimes is rock. Rock has a lot of geometric features associated with it. Let's see, where did the model go back? I adjusted so I'm really way up. So here's the shoreline. So this is the bird's eye view of what's going on. So maybe I want to take a look at that a little more closely. All right, so now it's up there somewhere. Let's see, did I put it way up? Oh. Yeah, let's see. Okay, maybe I should move back to like a remedial class. I'm going down to a C here. All right, there, right up close. So here I've got some rock, and that's actually pretty good. I'm surprised I didn't do that. All right, but you can see that there are a lot of features. I need to bring my hand down so I don't set off something again. But rock has a lot of structure associated with it. So the planes of weakness are really what drives the way rock works. So you can see that we have some cracks here. So this information can be very valuable to our geologists back in the office. And so if we have drone or UAS, UAV technology to get out for areas where we really can't take a look for ourselves, we can look at all these features and be able to share this information. And then perhaps we can ascribe some colors to it so that we can look at the major fault jointing and planes of weakness for what we think might slip and fall out again for future work that maybe needs rock bolting or something else to help with remediation. So we took a look at that, some other shoreline difficulties, and now we're going to sail off to the last portion of the presentation. So we have this bridge that needs to be constructed. And this is an area with some soft soils, has some seismicity associated with the project. So we're going to want to take a look at what's going on in the subsurface. So this is my favorite part. So there, it looks like we're locked in a little bit. So I've got the boring legend. So right now we've represented our borehole data. We have a type of test, the standard penetration test. It's represented by these discs for the intervals that it was taken. The color of the discs represent types of soil, and the diameter or the radius of the disc has to do with the strength of the soil. So where the diameter is greater, the soil is stronger. The actual bridge underpinnings are the pilings over there on one side, and presumably the bridge has another side to it. So I'm going to look over here and see, there it is, over there. So the bridge is between that and that, and then looking at the rest of the data. But we might not have enough data, so we might want to go out and do a different type of test. So that was standard penetration tests. I've now flown in some of these things that look like table legs or dowels. This is a cone penetration test. They can be performed somewhat faster. So we've got a different type of data, a lot more density associated, but still in the vertical domain. So you're still limited, but compared to plan sheets, you can walk around and take a look and see what's going on and where you might need to get more data. My colleagues and geologists like to do exploration geophysics. So this is the colorful planar plots, depending on whether or not you run seismic or resistivity. You can inject current into the ground, or you can hit a hammer and introduce a seismic pulse. And that'll give you information on the properties from the ground surface. You lay them out in lines, and you can get some information that helps augment the type of investigation for what you're looking for. So in these particular colored plots, the reddish indicates more dense soils or soils of better quality, and the greenish areas are perhaps soils that we might want to be a little more curious about in terms of our design information. But you can imagine that if everyone in the room had a lens like this, you'd be able to walk around. Perhaps your mastery of it would be somewhat better than my own. You could all get at least, A- as opposed to a kind of a C. But I think considering it was a real-time demonstration, it actually worked fairly well. Hopefully you're all still seeing a bunch of borings out in space. Yes? Are we good there? All right. I'm actually going to work over here for a look at this monitor out of the corner of my eye. Better than I thought. All right. That's what I wanted to share with you today. There are a lot of folks that are really making the future happen, I think, faster than I'm prepared for. I'm a geotechnical engineer by my trade and profession, and I am amazed at what aiming engines and other techniques and things that folks have been talking about today have brought to my profession. As part of the Federal Highways Everyday Counts initiative, we're working on a program to roll out new types of investigation that can expedite geotechnical investigation and perform our projects faster with better data quality. But the really interesting thing is all of that data now is digital. We have global positioning information, we have measurement while drilling, we have digital information that's flowing in, and our digital information is becoming an important asset to the infrastructure. And the real power of all that digital data is it's now easy to exchange and visualize the data so that I can share it in 3D space where it was really meant to be to convey its importance, more so than an 11 by 17 plan sheets, which I've actually had contractors tell me they do not look at during procurement. So I appreciate your time this afternoon. I am thankful the tech worked, so thank you so much. It's been a pleasure to be here today and share the virtual world with you. Thank you.
That was cool. Any questions? Are you gonna, this will be in the tech demo, right?
Yes, I'll be around this evening, so you can put it on and try it out. I've got a smaller model that's about 1 meter by 1 meter. But yeah, really cool stuff. So.
And I'll be there, I forgot to mention.
Okay, great.
I'll be demonstrating the reception.
Are you still planning to set something up as well? Or was your predecessor, before you got on board, said maybe to have a space available?
All right, okay. Actually, because our development was meant to be portable, just needed.
Okay, great, great. Any questions for Deb? Everybody's thinking about that snack. All right, well, thank you. And again, there's going to be a reception with food and I think beverages and lots of technology. There's a poster session as well as several demos. We have a VIZ set up and obviously some of this other cool stuff. So come on by. Thank you.